Hello students, welcome to today's lesson presentation on equations of straight line, a form 2 topic in mathematics, with a special focus on question 1 that is on the screen. It reads, part A, find the equation of a straight line L1 that passes through the points P, -6, -3, and Q, 1, 3 in the form AY plus BX is equal to C, where A, B, and C are constants. Now, for us to be able to solve this question, we have been given points P and Q as -6, -3, and Q as 1, 3. So we need to find the gradient of this line, and the gradient is given by change in y over change in x. So we take the y ordinate of Q minus the y ordinate of P over the x ordinate of Q minus the x ordinate of P. So in this case we take 3 minus 3 over 1 minus 6, and this gives us 6 over 7. So on that line PQ, there's another unknown point xy on it. So we use that the coordinates of that unknown point xy and either coordinate of P or coordinate of Q. So in this case I have used coordinate of Q. So we take y minus 3 over x minus 1 is equal to that gradient 6 over 7. Then cross multiply 7 into y minus 3 is equal to 6 into x minus 1. Simplifying or opening up the brackets, we get 7y minus 21 is equal to 6x minus 6. Then the question is asking us to express in form of ay plus bx is equal to c. So we bring 6x to the left side of the equal sign, and the equation becomes 7y minus 6x is equal to 15, which is in the right format that is required. For question 1b, it reads, a second line L2 is parallel to L1 and passes through to -3. Find the equation of L2 in the form y is equal to mx plus c. So we need to understand that parallel lines have equal gradients. So the gradient of line 1, which is 6 over 7, equals the gradient of line L2, which is also 6 over 7. So we take y minus 3 over x minus 2 is equal to 6 over 7, which simplifies to y plus 3 over x minus 2 is equal to 6 over 7. Now cross multiply, we get 7 into y plus 3 is equal to 6 into x minus 2, which simplifies further to 7y plus 21 is equal to 6x minus 12. Then we organize so that we remain with y on one side. That means we remain with 7y is equal to 6x minus 33. So that means when plus 21 crosses the equal sign, it becomes minus. So that means minus 12 minus 21, it gives us minus 33. So divide each term by 7, we get y is equal to 6 over 7x minus 33 over 7. So this equation is in the form of y is equal to mx plus c, where m in this case is the gradient, which is 6 over 7, and c is the y-intercept, which is negative 33 over 7. So we have responded to the question. Question 1, part C. A third line L3 passes through 2, 3 and is perpendicular to L1. Find the equation of L3 in the form of AY plus BX is equal to C. So for this question, we need to have some understanding that the product of the gradients of perpendicular line is equal to -1. So that means M1, which is the gradient of equation L1, times M2, which is the equation of line L3, is equal to -1. But the gradient of L1 is 6 over 7. So 6 over 7, M2 is equal to -1. Therefore, M2 is equal to -7 over 6. We have been told that the line passes through point 2, 3. So using that point and a known point, xy, so we get y minus 3 over x minus 2 is equal to -7 over 6. When we cross multiply, we get 6 into y minus 3 is equal to -7 into x minus 2. Opening up the brackets, we get 6y minus 18 is equal to -7x plus 14. They want us to write in the form of AY plus BX is equal to C. So that means we bring -7x to the left side of the equal sign. Therefore, it turns to be a plus. So the equation becomes 6y plus 7x is equal to 32, which is the right format that the question is asking us to write into. So that means the required equation of the straight line is actually 6y plus 7x is equal to 32. So we have responded to that question. Then part D, the question is asking us to use matrix method to find the coordinates of R. To find the coordinates of R, the point where L1 and L2 intersect. So for us to be able to solve this question, we need to have some understanding that the point of intersection is actually solving the given equations, the two equations of straight line simultaneously. So that means the equation of L1 was 7y minus 6x is equal to 15, and the equation of L3 that we have just found up there in part C, it is 6y plus 7x is equal to 32. So for us to be able to solve the values of y and x using the matrix method, we need to write the equation in the matrix format, which becomes 7, -6, 6, 7 into yx is equal to 15, 32. Then we let the matrix A to be 7, 6, -6, 7. Determinant of this matrix is gotten by the product of the elements in the leading diagonal minus the product of the elements in the other diagonal. So the leading diagonal gives us 7 by 7 minus the product of the element in the other diagonal is 6 by -6. So this gives us 49 plus 36, which gives us 85. So we are also required to find the inverse of this matrix. And how do we find the inverse? We say inverse is equal to 1 over the determinant, and the determinant is 85, therefore is 1 out of 85, into, we interchange the elements in the leading diagonal. That means 7, the bottom 7 moves up and the upper 7 moves down. Then on the other diagonal, we only change the sign. If the sign is negative, it becomes positive, and if the sign is positive, it becomes negative. So in our case, the negative 6 becomes 6, and 6 becomes negative 6, the way I've written on the screen. Now simplifying that expression, it gives us 7 out of 85, negative 6 out of 85, 6 out of 85, 7 out of 85. So that is the inverse of matrix A. So we pre-multiply this matrix on the matrix equation. We pre-multiply. So pre-multiplying, that means you bring it before the expressions on the left and also before the expression or on the right of the equal signs, the way I've done it in the solution there. Now if you simplify on the left hand side, it gives us yx. Then if you simplify on the right hand side, it gives us y is equal to 3 and 42 out of 85, and x, it gives us 1 and 49 out of 85. But now the question is asking us to find point R, the coordinates of point R, and coordinates are written in terms of x, y. So point R will be given as 1 and 49 out of 85, comma 3 and 42 out of 85. So that is the point of intersection of line L1 and L3. So we shall have responded to the question. I want to repeat. The values that we have gotten, the x and y, these are just the coordinates of the points of intersection. But if we are to write in coordinate form, then point R, we begin by the x ordinate, which is 1 and 49 out of 85, comma 3 and 42 out of 85 in brackets. That's the coordinate of point R, which is the point of intersection. So we shall have solved the two simultaneous equation by matrix method, which is a form 3 subtopic in matrices. Thank you.